I never asserted to absurd proposition as that anything might arise without a cause. Similarly, P.J. Zort, in his publication About Time, said, if there is anything we find inconceivable, it is that something could arise from nothing.
So, where did the universe come from? Why does the universe exist instead of just nothing? There must have been a cause which brought the universe into being. We can summarize our argument thus far as follows. Premise 1. Whatever begins to exist has a cause. 2. The universe began to exist. 3. Therefore, the universe has a cause.
So we're faced with two worldviews. One starts in the beginning with mass energy, the particles, and everything is derivative, including information. The other says the exact opposite. So in the first worldview, mass energy is primary and mind is derivative. In the other worldview, mind is primary and mass energy is derivative. And so far as tonight's lecture is concerned, it is the diametrical opposition between the worldview of materialism and the worldview of theism. It is a conflict between these two worldviews, but I want you to notice there are scientists on each side of it.
Now, what's the better candidate? Now, abstract objects, the problem with these abstract objects is they're causally effete, but they can't cause anything. Like, for example, the number 1 can't cause anything.
The simple law of arithmetic, 1 + 1 = 2, never brought anything into being. I wish it did. It never has put any money into my bank account. If I put £1,000 into the bank today and later another £1,000, the laws of arithmetic will rationally explain how it is that I now have £2,000 in the bank. But if I never put any money into the bank myself and simply leave it to the laws of arithmetic to bring money into being, I shall be permanently bankrupt. C.S. Lewis, with usual brilliance, grasped this years ago. The laws of nature produce no events. They state the pattern to which every event, if only it can be induced to happen, must conform. Just as the rules of arithmetic state the pattern to which all transactions with money must conform, if only you can get a hold of any money. Thus, in one sense, the laws of nature cover the whole field of space and time. In another, what they leave out is precisely the whole real universe. The incessant torrent of actual events, which makes up true history, that must come from somewhere else. To think the laws can produce it is like thinking that you can create real money by simply doing sums. For every law says in the last resort, if you have A, then you will get B. But first catch your A. The laws will not do it for you.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
These are numbers like the mass, the weight of an electron, the weight of a quark, the strength of gravity, the strength of the electromagnetic field. About 20 numbers that describe those and other parameters, features of our world, but nobody knows why it is that those numbers have the particular values that they do. Now, you could easily say, yeah, who really cares? You change the mass of the electron by a little bit more, a little bit less. Does it really matter? And the answer is it does. See, it turns out that if you imagine that we had 20 dials right here, and we could fiddle with those 20 numbers at will, even a small change to the values of the known values of those numbers would cause the world as we know it to disappear.
Because it turns out, and this is a very surprising, unexpected discovery, that the laws of physics, the basic given fabric of the world, had to be very specific, very finely tuned, as we sometimes say, for the possibility of carbon-based life appearing at all.
For example, the strengths of the other forces are all important, the masses of the various subatomic particles. Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
It's a very surprising conclusion, but it's true, and all scientists will acknowledge that's the case.
Bernard Carr is a cosmologist and studies how the laws of physics operate in the universe. He says that the laws of nature are so finely tuned to enable complex life to exist that it is extremely unlikely that this could have happened by chance. Such fine-tuning, Carr believes, at least raises the possibility of a tuner.
This is a diagram, it's called the pyramid of complexity, and what we've got here, we've got the different levels of structure in the universe, and at the bottom we've got the things like quarks that make up the atoms, and the atoms build up to make molecules, the molecules build up to make living cells, the cells make organisms, and eventually we end up with brains and consciousness. It's rather hard to estimate what the probability is, but it was clearly very, very unlikely that those fine-tunings which allowed this pyramid of complexity to arise would be there.
A very simple and central example is the question of where does carbon come from? The very early universe doesn't make any carbon. It's very simple, it only makes simple things. Hydrogen and helium, and they're pretty boring in terms of chemistry. Now, where does carbon come from? There's only one place in the whole universe where carbon is made, and it's in the interior nuclear furnaces of the stars. We are people of stardust, made of the ashes of dead stars. And it turns out that the process by which the carbon is made inside the stars is an extraordinarily delicate process. In fact, it looked at first sight as though it couldn't happen at all. It's only possible because there's a very large enhancement effect, called a resonance in the tray, which makes it go much quicker than we might have expected. And that resonance is there because the laws of nuclear physics take a very specific form. If they were a little bit different, either there would be no resonance or it would be in the wrong place at the wrong energy. That's a very striking example of how finely tuned the universe has to be for us to be inhabitants of it.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question.